Today's lesson is about section 2.4, interior and exterior angles. Now, before we talk about everything that we need to discuss, first thing we need to clarify is the difference between concave and convex polygons. All concave polygons have at least one interior angle that is greater than 180 degrees. For example, if you look at this polygon, this angle is less than 80, this is less than 80, this is less than 80, and that's less than 80. But this angle here is greater than 180 degrees, and that is the reason why that polygon is called concave polygon. As opposed to concave polygons, convex polygons have all angles that are less than 180 degrees. And if you look at all of these examples, you can see that all of them have all angles as such. Now, all polygons that we are talking about this year are convex polygons. So everything that we have mentioned so far and that we will mention is related to convex. So within convex polygons, first thing, you know that every polygon has interior angles. And in this drawing here, this is a pentagon, has 5 sides. Angle 1, 2, 3, 4, and 5 are inside of that pentagon. They're all interior angles. Now, at every vertex of this pentagon, if we extend the side, like for example, you see this side, if I extended, I am actually creating, with this interior angle 2, I am creating an exterior angle, which is angle 7. So that's the angle at the same vertex as angle 2, but it's outside of that polygon. The same with angle 1. This is angle 1, that's interior angle. Angle 6 is exterior angle created with it at that vertex when I extend the side of the polygon. And you can see it's the case with every interior angle of a polygon has its matching exterior angle that is outside. Now, one thing that you need to recognize is that every time you create exterior angle and when you add it to interior angle, you always have that straight line, which is actually 180 degrees. So the sum of an interior and an exterior angle at any vertex is always 180 degrees, and that's this rule here. Interior angle plus exterior angle at the same vertex equal 180 degrees. And you can use that rule for later on to figure out the missing angles that we need to find out. Now, another thing that we need to answer is, what is the sum of all exterior angles of any polygon? So guys, you remember from our investigation, any time that the number of sides of a polygon increases, the sum of all interior angles goes up, which means that all interior angles are becoming bigger and bigger as the number of sides increases of a polygon. But what happens with that is, if this interior angle goes up because I have more sides, then the exterior angle has to go down because the sum of all interior and exterior angles at the same vertex is always 180, cannot change. So because of that, the sum of exterior angles never changes. It's always 360 degrees, always. And you can use that fact to find the missing angles when you know certain angles of a polygon. So let's look at that. Let's look first at the first one, first example. So what we have here, we have a pentagon, 1, 2, 3, 4, 5 sides. We know 4 of these exterior angles of that pentagon, but we need to find how much is y. So the sum of all exterior angles is 360. We know that, am I right? So if we take 360 and if we subtract all of these exterior angles, we will find how much is the one that is missing. So we subtract the sum of all of these. So 70 plus 60 plus 65 and plus 40. So by order of operation, we have to solve that first. So this is 130, 170, 235. So if we take 360 minus 235, we should find how much is angle Y. So that should be 360 minus 235 is 125 degrees. That's my angle Y. So 125 degrees is angle Y. Now, if we look at the other example here and we want to find the missing angle, we can actually combine the rules that we know. First of all, we know that the sum of all angles of a triangle, all angles in a triangle is 180 degrees. That's one thing that we know for sure. So we can actually use that to find this angle here. We want to find this missing angle, and let's call it CTA. So angle CTA. To find that angle, we actually have this straight line, which means that this angle and then angle of 121 degree are supplementary to each other. They add up to 180. So to find it, we can just take 180 minus 121, and we will find that that angle is equal to 59 degrees. Now when we know that this angle is 59 degrees, and we also know that this angle is 16 degrees, we know that this angle here has to add with them total of 180 degrees. So to find angle C, I can name it angle C because there are no more than one angle there. Angle C would be actually equal to the sum of all angles of a triangle minus the two that we know, 59 plus 16. So that will be 180 minus, this is 69.75, and we have that angle C is equal to 105 degrees.